Greetings, class. Just a little bit of more information about the z-table and the use of the z-probability distribution, and also some practical application. I wanted to draw your attention to a couple of documents that you'll find on Blackboard. One is called Exercise 1, Introductory Exercise to the Z-Table. And that document contains 11 problems that you can solve in order to test your use of the z-probability distribution, the table. And then the other document that's closely related to it is called Exercise 1, Introductory Exercise to the Z-Table Answers. And as you can probably guess, that document contains the answers to the worksheet. So my recommendation would be to download and print the document that has the problems, see how well you do, then download the answers and compare and assess yourself. The other document I wanted to call your attention to is called Z-Table Examples, and that document has, goodness gracious, how many? 8 examples of problems that you're going to need to know how to do in order to successfully complete problem set number 4. And so my recommendation is that you download and print that document. Again, the document I'm referring to, and actually the first page is right here. That document I'm referring to is called ztableexamples.pdf, and it's kind of it's a little bit of a generic document in that I don't add a whole lot of detail or color, if you will, to it. But just looking at in fact, go ahead and pause this video if you don't have that document and go get it, and then come back and we'll continue. This first sheet on that document, example number 1, so have that in front of you. I won't hold it up the whole time. But I will point out a couple of things. All of these examples ask you to assume some specific information. Specifically, I'm asking you to assume a mu, or population mean, of 7, and a standard deviation, or lowercase sigma, of 3. And you can see that right here. Mu of 7, standard deviation of 3. All right, so that is just an assumption. That is just a given. All right, so assume a mean of 7 and a standard deviation of 3, and we're talking about a population. The problem, or the item to be solved, is, as you can see if you're looking along with this worksheet, what portion of the population scores less than 2 points? Okay. So we have a population that took a test. A population that took a test, they scored a mean of 7 and a standard deviation of 3. And the question we need to solve is what portion of the population scores less than 2 points. Now, the first thing I did is draw a picture of the normal probability distribution, which you can see right there. I drew that picture, I drew that bell curve with nothing else on it. That's number 1. Draw the normal probability distribution. The next thing I did was, once I had my normal probability distribution, I drew 2 more lines underneath the abscissa, here and here. 2 more lines underneath the abscissa. And the top line is going to contain z-scores, and the bottom line is going to contain raw scores. Okay? So step number 1, draw the normal probability distribution. Step number 2, draw 2 lines under the abscissa. The top line is going to contain z-scores, the bottom line is going to contain raw scores. The next thing I did was in the middle, the next thing I did was draw a line down the middle, splitting that drawing in half, and I put a z-score of 0 right in the middle. Z of 0 is always in the middle. Always in the middle, 0. Z of 0. So my z-score of 0 goes right in the middle, and also my population mean goes in the middle on the line below. All right? Z-scores, data. The top line is z-scores, the bottom line is data. So I have my normal curve, I've got my 2 lines under my abscissa. Top line is going to be z-scores, bottom line is going to be raw scores. I got a z of 0 in the middle, I've got a mean of 7 in the middle. All right, that is what we know. All of that was given as part of the problem. The question is, what portion of the population scores less than 2 points? Think about that. What portion of the population scores less than 2 points? Points. What are we talking about there? We're talking about data, right? Scores. This population had a mean of 7, a standard deviation of 3, and the question is asking about a raw score of 2. Again, what is the question? What portion of the population scores less than 2? So I went ahead and that's another item that I know. A raw score of 2 is going to fall there. How do I know it's there? Because 2 is less than 7. 2 is less than 7. 2. Okay, so now I have a raw score. Well, guess what the next thing I did was? I need to use the z-table to solve this problem. Well, the z-table doesn't talk about points. The z-table talks about standard deviation. So the next thing I need to do is convert that raw score of 2 to its corresponding z-score. And luckily, I have all the information that I need to do that. I know it's kind of small, but hopefully you're looking at it along with this. The z formula, z equals x minus mu, the mean, divided by lowercase sigma, the standard deviation. Z equals x minus the mean divided by standard deviation. All I got to do is substitute. Z equals what's x? In this case, in this example, this problem, it's 2. 2 minus 7 divided by 3. Z equals negative 5 divided by 3. Z equals negative 1.67. Boom! Now I have a z-score. And that z-score goes right there. Z equals negative 1.67. Now all I got to do to solve the problem is consult the z-table. But wait, there are no negative z-scores on the z-table. What am I supposed to do? How can I figure this problem out? No problem, because of the the property of symmetry. I won't find a z-score of negative 1.67, but I will find a z-score of 1.67, and that works just as well. So I go to the table, the z-table, and I look for a z-score of 1.67, and I find, guess what column solves the problem? Column B, the area between the mean and the z-score, or column C, the area beyond z? Well, again, let's look back at the question. What portion of the population scores less than 2? Where is that portion going to be? That portion is going to be right there. So I need to know how big that portion is. That is the area beyond z, beyond. And that area is 0.0475. And that answers the question. So as a recap, I drew the distribution. I put the lines under my abscissa. The top line is going to be my z-scores. The bottom line is going to be my raw scores. I cut that distribution in half with a vertical line. I charted my z-score of 0 in the middle, my mean of 7 in the middle. I went to the question. The question is, what portion of the population scores less than 2 points? So I put x equals 2 right there. This is raw scores right here. This line, the bottom line, raw scores, data, right? X of 2. I then converted that score of 2 to its corresponding z-score, negative 1.67. I then consulted the z-table, and I found, according to the z-table, that a z-score of, in this case, negative 1.67 has 0.0475 of the distribution beyond it. That answers the question. What portion of the population scores less than 2 points? The answer is 0.0475. If I were to express that as a percentage, it would be 4.75%. So the answer is not much.